you ever looked at a snowflake and wondered how it formed or why it looks different from other snow you might have seen? We all know snowflakes are beautiful, but what are they and where do they come from? Join me, James Rice, for the next few minutes as we explore the mystery of these tiny wonders with materials found on Wikipedia and from across the web via Google. Snowflakes all start out as water molecules. Snowflakes are a particular form of water ice. Snowflakes form in clouds, which consist of water vapor. When the temperature is 32 degrees Fahrenheit, or 0 degrees Celsius, or colder, water changes from its liquid form into ice. Several factors affect snowflake formation. Temperature, air currents, and humidity all influence shape and size. Dirt and dust particles can get mixed up in the water and affect crystal weight and durability. The dirt particles make the snowflake heavier and can cause cracks and breaks in the crystal and make it easier to melt. Ice crystals formed in well-controlled laboratory conditions are often thin and flat. These planar crystals may be in the shape of simple hexagons, or if the supersaturation is high enough, develop branches and dendritic, or fern-like features, and have 6 nearly identical arms. The 6-fold symmetry arises from the hexagonal crystal structure of ordinary ice. The branch formation is produced by unstable growth, with deposition occurring preferentially near the tips of the branches. The shape of a snowflake is determined broadly by the temperature and humidity at which it is formed. Rarely, at a temperature of around -2 degrees Celsius or 28 degrees Fahrenheit, snowflakes can form in threefold symmetry, triangular snowflakes. The most common snow particles are visibly irregular, although near-perfect snowflakes may be more common in pictures because they are more visually appealing. Generally, 6-sided hexagonal crystals are shaped in high clouds. Needles or flat 6-sided crystals are shaped in middle-height clouds, and a wide variety of 6-sided shapes are formed in low clouds. Colder temperatures produce snowflakes with sharper tips on the sides of the crystals and may lead to branching of the snowflake arms, or dendrites. Snowflakes that grow under warmer conditions grow more slowly, resulting in smoother, less intricate shapes. From 32 to 25 degrees Fahrenheit, thin hexagonal plates. 25 to 21 Fahrenheit, needles. 21 to 14 Fahrenheit, hollow columns. 14 to 10 degrees Fahrenheit, sector plates, and 10 to 3 degrees Fahrenheit, dendrites. Now you may wonder, why are snowflakes symmetrical? Not all snowflakes are the same on all sides. Uneven temperatures, presence of dirt, and other factors may cause a snowflake to be lopsided. Yet it is true that many snowflakes are symmetrical and intricate. This is because their shape reflects the internal order of the water molecules. Water molecules in the solid state, such as in ice and snow, form weak bonds, called hydrogen bonds, with one another. These ordered arrangements result in the symmetrical, hexagonal shape of the snowflake. During crystallization, the water molecules align themselves to maximize attractive forces and minimize repulsive forces. Consequently, water molecules arrange themselves in predetermined spaces and in a specific arrangement. Water molecules simply arrange themselves to fit the spaces and maintain symmetry. Is it true that no two snowflakes are identical? Yes and no. No two snowflakes are exactly identical, down to the precise number of water molecules, spin of electrons, isotope abundance of hydrogen and oxygen, etc. On the other hand, it is possible for two snowflakes to look exactly alike, and any given snowflake probably has had a good match at some point in history. Since so many factors affect the structure of a snowflake, and since a snowflake's structure is constantly changing in response to environmental conditions, it is improbable that anyone would see two identical snowflakes. All these mysteries and more have fascinated scientists for generations, and even today, not all of the properties of water's molecular bonding and ice crystal formation are known yet. But enjoy this last slide, and thank you for your time.